welcome back, guys. This is section 3.3 continued, solving systems of inequalities by graphing. In the previous video, we graphed strictly linear inequalities. This one, we're going to do a couple examples with absolute or a combination of both. So, crazy stuff. Let's start off with a combination of both. I have a linear inequality and an absolute inequality. Let's start with the linear. Let's graph it. The first thing I need to do is to get y by itself. So I need to divide by 5. So y is greater than or equal to 2/5 x minus 1. And let's graph that. So my y-intercept is at -1. And my slope is up 2 and to the right 5. Up 2 to the right 5. And we can plot our line. It is a solid line. Let's see how straight I can get this. Not bad. Okay, so lastly I need to shade. This tells me that I need y values that are greater than or equal to 2/5 x minus 1, our line. So I will shade above. Alright. So let's take a look at our absolute value inequality. Now remember, our parent function or our absolute value, sorry guys, PE jumped in on that conversation, opened the door, and started talking. So anyway, back to the problem. Let's take a look at our absolute value function or inequality. If you remember, our parent function or our absolute value function without any transformation at all looks like this, with a vertex at 0, 0. Okay, so I'll kind of draw a little mini graph off to the side. A vertex 0, 0, and it's shaped like a V. Okay, so here we have one transformation. We have a +3 inside the absolute value function, which basically means we have a horizontal translation, and if you do the opposite of what it says. So I'm going to move 3 units to the left. 3 units to the left, and that will be our vertex. -3, 0 is our new vertex. Okay, so we can draw, do I have a solid or dashed line? I have a dashed line. Okay, so I'm just sketching this. Now, if I ask you to be precise with your points, then I'll ask you to do an XY chart, and then you'll plot your XY values. But for now, we're just going to do a rough sketch. Okay, so we need to choose values that are, for our shaded region, that are less than, or y needs to be less than our graph. Okay, so I am going to shade below. I'm going to shade below. And we can see our region of intersection right here. Okay, now I'm not going to include anything that touches our dotted line. These points are not included. But anything on our solid line, yes, that is included. So again, just like we did in the previous video, you can choose a value somewhere in this region and see if it works for our equation, and it should. Okay, let's do another example where we have an absolute value inequality as well as a linear inequality. Let's work with our absolute value inequality and graph it. Again, our vertex moves. In this case, it's going to move 3 units to the right. 3. We have a horizontal translation. If I were to have something on the outside of this, like a -1, then our translation would be 3 units to the right and also down 1 unit. That would be our vertex. So, but for now, we're just going to work with the -3. Okay, so our vertex is here. We have a solid line. Let's sketch this. Absolute value, okay? And where do we shade? Well, y has to be greater. Y values have to be greater than this. Let me erase that one. So I'm going to shade above the graph, or kind of inside the graph, you could say. Okay, and now let's graph y is less than 4. Again, we know this means that it crosses the y-axis at 4. So let's plot that. 1, 2, 3, 4. And we have a dashed line. We have a dashed line. Now where do we shade? Well, it says y is less than 4, so we choose values that are less than 4. And we shade here. Anywhere below the dotted line. Where do our points overlap? They overlap in this section, maybe kind of outlining it here. They overlap in this kind of triangular section. Of course, not including what's dashed though. Okay, I know I outlined it here, but you wouldn't include values where you have a dashed line. Alrighty, that is all that I have for you today. We'll see you the next time.